Alright, so let's look at this topic A review. So we have some graphs on the first page. So the first thing we're going to do is make an XY table. So we have -2, -1, 0, 1, 2. Let's just and remember, anything to the 0 power is 1. And our growth rate is 4. So we have 1, 4, 16, 1/4, 1/16. Then our third row is going to be 1/4 times y from right here. So 1/16 times 1/4 is 1/64, and I'm just using a calculator for that. 1/4 times 1/4 is 1/16. 1 times 1/4 is just 1/4. 4 times 1/4 is 1. And 16 times 1/4 is 4. So then we ignore this. And we're going to graph these x values with these y values. So -2 comma 1/64 is going to be really close to 0. -1 comma 1/16 is also going to be really close to 0. 0 comma 1/4, 1 comma 1, and 2 comma 4. So this is our graph. Now because of this +1 right here, that means every point is going to be shifted to the left 1 unit. So I'm going to take this, shift it left 1. This, left 1. So all these points I'm just shifting left 1 unit. Oops, did not want to delete that. Okay. So that blue line is our final graph. This is exponential growth because A is positive and our B value is bigger than 1. Domain. Domain for this exponential function is going to be -infinity, comma infinity. The range, the smallest y value we get to is y equals 0, but we never touch y equals 0. So we have 0, comma infinity. The y values are going up. Our asymptote is going to be y equals the y value in our range. Y equals 0. Our end behavior, the left side of the blue graph, keeps going down and it approaches our asymptote, which is y equals 0. So as x approaches -infinity, y approaches 0. And as x approaches +infinity, the y values are going up. So let's look at the next graph. Now we have this -7 on the outside, which means our whole graph will be shifted down 7 at some point. So an x, y table. Now notice we don't have an a value. We don't have a number in front like we did in number 1. We had this 1/4 in front. We don't have that. So in our xy table, we're still going to do -2, -1, 0, 1, 2. And 2 to the 0 power is 1, and our growth rate is 2. I'm not going to do that third row because we don't have an a value. So now 0, comma 1, 1, comma 2, 2, comma 4, -1, comma 1/2, -2, comma 1/4. So our graph will look like this. Now that, again, that minus 7 means we're going to shift all these points down 7 units. So our graph will act, whoops. Our graph will look like this. Because remember how this negative 7 will be our new asymptote. So this, again, this is exponential growth. Domain, negative infinity, comma infinity. The range, the smallest y value we get to is negative 7, and we go all the way up to positive infinity. So negative 7, comma infinity. Our asymptote, y equals negative 7. Transformations, that is our RST. There was no reflection. There was no shrink or stretch. We didn't have an A value, but we were translated down 7. Alright, let's look at number 3, where we're going to have 2 transformations, and we have an A value. So this one kind of deals with everything we have. So let's start with our table. We have negative 2, negative 1, 0, 1, 2. Anything to the 0 power is 1. And now our growth rate is 1/2, so 1/2, and 1/4. And going backwards, 2 and 4. Now we have an A value here of 4, so 4y. Take all these y values and multiply them by 4. 4 times 4 is 16. 2 times 4 is 8. 1 times 4 is 4. 1/2 times 4 is 2. And 1/4 times 4 is 1. So let's ignore the middle one, negative 2, comma 16. And it's going to be off the graph. Just estimate that. Negative 1, comma 8. 0, comma 4. 1, comma 2. And 2, comma 1. So without any shifting, this is our graph. Now we are shifted right 3 and up 1. So I'm going to take each of these points and go right 3. 1, 2, 3, up 1. Each point is going right 3, up 1. And up here, you can, again, just try to estimate your best. So that green graph is our final function. And because our B value is less than 1, this is decay. Our domain, negative infinity, comma infinity. Now the range, the smallest y value we have is positive 1. It was our outside number up here. So range will be 1, comma infinity. Asymptote will be y equals 1. Now the end behavior. Look at the left side's going up of the green graph and the right side is going down. So the left side, as x approaches negative infinity, is going up, so y approaches positive infinity. And now the right side, as x approaches infinity, the y values are approaching my asymptote, which was 1. So this problem had a little bit of everything in it. Alright, next one. Now this has a negative a value. There's a hidden -1 there, so you could think of it as -1 times 5 to the x, if that makes it a little bit easier to see what's happening. -2, -1, 0, 1, 2. Anything to the 0 power is 1. Our growth rate here is 5. So this one is going to get off the page pretty quickly. Now, because we have a negative a value, we got to multiply all our numbers by -1. And then we'll graph. -2 comma -1 over 25 is really close to 0. 0.0 comma -1, 1 comma -5, and 2 comma -25 will be way down here. So this will look like that, and we have no shifting. Because our a value is negative, that means this is not exponential growth or decay. It is neither. Domain is -infinity, comma infinity. The range, though, the y values go all the way down to -infinity and up to 0. That makes our range -infinity, comma 0. Asymptote will be y equals 0 again. And our end behavior, the left side is getting closer and closer to 0. So as x approaches -infinity, y approaches 0. And the right side, as x approaches +infinity, y approaches -infinity. Alright, so that is our graphs. Let's turn over and look at the other side. Alright, so this page we have to mostly write equations from graphs and tables. Look at this function here. It's an exponential function. And the reason we know that is because the y values are being reduced by 1/2 each time. If you're given a graph and you're trying to figure out the equation from a graph, look at two consecutive points. We can look at this point, and then divide the y values. We're going to do the later one, and when I mean later one, like the more to the right divided by the left one. 2 divided by 4 is 1/2. You can do the same thing with any 2 points. You know, if we use these 2 points, right, we take 1 divided by 2, oh, that's 1/2 as well. So no matter what 2 points you use, as long as they're next to each other, you would divide the y values to get your growth rate. So now my function becomes y equals, our y-intercept is 1 times 1/2 to the x power. You don't need the 1 out in front. Now the end behavior, as x approaches -infinity, the right side's going up, y approaches infinity. As x approaches +infinity, the y values are going towards 0. So that is that graph. This function is a line, so it is a linear function. That's a family. The equation, we need the slope and y-intercept. Slope looks like it's up 2 and right 1, so 2x, and our y-intercept is +3. So that is our equation. And then the domain and range for linear functions, -infinity, comma infinity, for both of them. Now, this table, we look at the x and y values. The x values are -1, 0. So the x values are going up. The y values, -1, -1, -1, and then +1. They're going down and then up by the same amount. That tells us that this is an absolute value equation. So, absolute value. Now the equation, we want to find the vertex, which is right there. That's where we changed from subtracting 1 to adding 1. And we have y equals x minus 2 plus 1. And now we got to figure out the slope. The y values are going down by 1 and then up by 1. So the a value will be a positive 1. You don't have to write a positive 1 in front. You can leave it alone, or you can put it in there. All right, letter D. We have 3, the y value is 3, 6, 12, 24, 48. So they're being multiplied by 2 each time. That tells us it's exponential with a growth rate of 2. But we need to find the y-intercept. Right now we have x equals 1. We have to go back 1 and say, okay, if the x value was 0, what would y be? So 3 divided by 2 would just be 3 over 2. A equals 3 over 2. So this is an exponential function. And the equation would be y equals 3 over 2 times 2 to the x power. Right, so just remember that you always need to find out what the y value is when x is equal to 0. Alright. Here, Jessie loves to watch TV after work, but it was consuming too much of her time. Each week she decides to increase the amount of TV she watched. After 2 weeks she was down to 8 shows a week. After 3 weeks she was watching only 4 shows a week. On week 5 she chose to only watch 1 show. So you want to be careful with this one, because you may think that this is an exponential or linear function just based on some of the information. So we have 2 after 2 weeks. I'm going to make a small table here. After 2 weeks, 8 shows. 3 weeks, she was down to, says, 4 shows. We don't know anything about 4 weeks, but we know 5 weeks she was down to 1. Whoops, we want to get rid of this. Now the 4th week, okay, we say, all right, we go down by 4. We don't know what that is, but then we go down by the same amount. We're at 1. If this, you see, well, 4 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. Okay, so we have a dividing by 2, which is the same thing as multiplying by 1/2. So your b value is 1/2. Now the a value, we've got to go backwards. Just like I was saying in the previous problem, okay, how much was she watching at the very beginning? So instead of dividing by 2, we're going to multiply by 2. So we can clearly see the y values are being divided by 2 each time. This family is exponential. And the equation is going to be y equals 32 times 1/2 to the x power. I don't know what happened there. There we go. Alright. let's look over here. Sarah's buying a rug for her new nursery and looking at different sizes. Write an equation for the area of the rug as a function of its length. Okay, so I think we can see that as the y values are getting larger, it's not by the same amount. Like we're adding 5, then we're adding 7, then we're adding 9, and so on, and we're not even multiplying by the same number. But 2 squared is 4, 3 squared is 9, 4 squared is 16. So our equation would be y equals x squared. Right, now down here, we're going to do look at these tables and determine whether we have exponential growth, decay, or neither. So look at the y values each time. That's times 3 times 3 and times 3. So we're multiplying by 3 each time. And it is growth. And our equation will be y equals, we have our y-intercept right here, 12 times 3 to the x, because 3 is our growth rate. And what you can always do is take your calculator and double check and say, okay, if I plug in 2 for x and type this in the calculator, do I get 108? If I type in -1 for x, do I get 4? That's just something, if you have time to do that to double check. This one, I see that all my y values are negative, which means my a value is negative. We got to figure out what that will be. So I'm looking down here, and I see we're multiplying by 1/2 or dividing by 2. Times 1/2, times 1/2, times 1/2. But since the y values are negative, it is not growth or decay. Neither. We need to go up and figure out, okay, when x is 1, what's the y value? When x is 0, what is the y value? Because that will tell us our y-intercept. Right, if we're going to be multiplying by 1/2 as x gets larger, going backwards, we would be dividing by 1/2. So you can take -32 and divide by 1/2. You'll get -64. And -64 divided by 1/2 is -128. That is our y-intercept. So the equation becomes y equals -128 times 1/2 to the x power. And again, you can take your calculator out, type in 3, and you should get -16. Alright, last one. This one, I'm looking at the y values. And I say, okay, 45 divided by 3, divided by 3. Okay, we're dividing by 3 each time. So times 1/3, times 1/3, times 1/3. Well, we don't have x equals 0. So we got to multiply by 1/3 one more time, and we get 5/9. So then that makes our equation y equals 5/9 times 1/3 to the x power. Okay. So always remember, when you're trying to write an equation, you need to find out the y-intercept. Right, so I hope this helps, and good luck.